Hi there. I'm Josh, and my partners are Grace and Maggie. You can find more about us in our write-up. But yeah, I'm just going to be showing the simulation that we coded of our ecosystem. And I'm going to go ahead and share my screen and give a quick walkthrough before I turn off my video and microphone and just let the simulation run. Yeah, so here is the notebook that gets it done. This is a graphic simulator, which means you can see it happening. Um, so basically here we initialize the Pygame. We're using a Python library called Pygame. It allows us to code little games like this. Most of this is you can read about in the write-up. It's inspired by, it utilizes object-oriented design. So here we can see all these objects that are initialized in our ecosystem simulation. We even have some object inheritance here. Uh, and basically at each time stop, all of the deer and the humans move a little bit. So you'll see a jitter and the vegetation will stay in place and get eaten or stay alive. And we plot the population at every time stop. Um, enough about that. Let's get into running the actual code. So we're going to want to make sure that we, restart the kernel. Every time that we run it again, we want to restart the kernel. And sometimes you get a malfunction. It might be like a bug with Pygame, but sometimes we get a malfunction that if you press run all and try to run your simulation, it actually doesn't exactly work. So in that scenario, I would suggest force quitting Pygame, force quitting Python, restarting your kernel again, and then just trying to press run all once again. And sometimes it actually works, but the graphic simulation doesn't show up. In which case, it will where my mouse is, it'll say interrupt. You can press interrupt and then press run again, and it will show up. That's just what I've found out on my computer. Um, and yeah, this requires that you import Pygame and also pip install Pygame on your computer. All right, so let's get this started. And also, I'm running this for 30 years, so this might take a little bit. Um, in our write-up, we run it for 10 years, but here I'm running it for 30 years, so that way we can see, a longer simulation. All right, here goes. Okay, yeah, so here we just press interrupt and then run all, and here it is. Yeah, and with that, the simulation has concluded. We can see here if you want to find out where we are in the simulation, meaning how much time has passed. I made it so that, it's printing the current day. So each time stop is a day. So we simulated it for 30 years. This is 30 times 365. So if you want to get an idea of how much longer you have to wait, here's what you can look at. And let's look at our plots now. This is the populations over time, right? And we see that we actually have enough time to see little fluctuations in the population, which is actually what happens out in the wild. Basically, each trophic level, each organism will overconsume a little bit, leading to the depletion of food. So then, due to the depletion of food, a lot of those animals will starve, which allows the food to regenerate. So if we look at this plot here, which is basically the deer and the vegetation plotted together on like similar axes, we see that they really do resemble each other, but we see that every little increase in the deer population happens a little bit after the corresponding increase in the vegetation population. So every time the vegetation population increases, then the deer will follow with some delay. And every time the vegetation decreases, the deer will follow with some delay because it takes time for them to starve. And then when the deer starve, the population of the vegetation recovers. And yeah, that's our project. It was super fun.